Hello everybody, I am Ananthavalli from Education channel. Welcome to this new video from my channel. We are continuing class 11 chemistry, classification and periodicity of property. Periodic properties part 14. In this video, we are doing trend in chemical properties with special reference to valence or oxidation state. We will understand the terms valency, valence or oxidation state, and then charge. Before I sign off, I will also discuss how to calculate oxidation state. In chemistry, we mainly deal with chemical reactions. So it is very important to know the chemical properties of elements. Valence or oxidation state or oxidation number, all the three mean the same, is a very important concept. Watch the video completely and understand the concept thoroughly. If I was of any help to you, do not forget to like my video, share my video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and also press the bell button and all button for notification of more videos like this. Thank you very much. Come, we will start the class. Our topic is valence or oxidation state. Nowadays, instead of valence, the term oxidation state is preferred. So, in this consideration, we will be using the term oxidation state or oxidation number rather than valence. Many have difficulty in differentiating three terms, namely valency, oxidation state or oxidation number, and charge. So, I will first clarify them. Valency is the combining capacity of an element. It is a number. It depends on the number of electrons called valence electrons in the outermost shell. It is the number of electrons gained or lost or shared by an atom during a chemical reaction to complete the outermost shell. Electrons in the outermost shell are called valence electrons. These valence electrons decide the oxidation state. The outermost shell is also called valence shell because it contains the valence electrons. By the way, valence electrons take part in chemical reactions. Second one, oxidation state. It is a charge acquired by the atom in the combined state with a reference to the electronegativity of the other element. You will understand this better when we discuss how an oxidation state is calculated. The third point, charge. During chemical reaction, if an electron is lost by an atom, the atom acquires positive charge. It becomes a cation. On the other hand, when the other atom accepts the electron, it gains a negative charge. It becomes an anion. I will use one simple example to explain this. When sodium chloride molecule is formed, sodium reacts with chlorine to form sodium chloride. Atomic number of sodium is 11. Electron configuration is 281. And chlorine has atomic number 17. Electron configuration is 287. Sodium has 11 protons. That is 11 positive charges. Chlorine has 17 protons. That is 17 positive charges. When the reaction takes place, sodium gives away one electron to chlorine. So sodium loses one electron and its negative charges get reduced to 10. The number of positive charges remain the same, that is equal to 11. So it has now one proton or positive charge in excess. In the case of chlorine, it gains one electron and its total number of negative charges become 18. The number of protons remain the same, that is equal to 17. So chlorine has one electron in excess, that is it develops a negative charge. So sodium has one positive charge and chlorine has one negative charge. While representing, this one is omitted. If it is more than one, it has to be specified. So let us sum up. We will take the same example, sodium and chlorine. Number of valence electrons. For sodium, it is 1. For chlorine, it is 7. Valency of sodium is 1. Valency of chlorine is also 1. Oxidation state of sodium is +1, whereas for chlorine it is -1. Charge acquired by sodium is 1 plus, and for chlorine it is 1 minus. Note the sign for oxidation state and charge. For oxidation state, the sign is first represented and then the magnitude. For representing the charge, you write the number or magnitude first and then the sign. Now we will proceed to discuss the trend of oxidation state. Before we pass on to the trend of oxidation state or oxidation number, we will just see the oxidation state in the various groups. For elements in the first, second, 13th and 14th group, oxidation state is equal to the number of valence electrons. Valence electron in first group is equal to 1, and for the second group it is 2. First group and second group elements belong to S block. Valence electron in the 13th group is 3 and that of 14th group is 4. 13th and 14th group belong to the P block. So the oxidation states of the elements will be 1, 2, 3 and 4 for first group, second group, 13th group and 14th group respectively. So we find the oxidation state increases from 1 to 4, from first group to 14th group. The sign of the oxidation state for first group, second group and third group is generally positive. In general, we have to remember the sign of the oxidation state will depend upon the electronegativity of the other element with which it is combining to form the compound. For elements belonging to 15th, 16th and 17th group, that is from 15th to 17th, oxidation state is equal to 8 minus the number of valence electrons. Valence electrons for 15th group is equal to 5, for 16th group it is 6 and 17th group it is 7. As the valence electrons for group 15 is equal to 5, its oxidation state will be 8 minus 5 equal to 3. Similarly, for the 16th group, the valence electrons is equal to 6. Therefore, its oxidation state will be 8 minus 6 equal to 2. 17th group elements have 7 electrons in the valence shell. That is, the valence electrons are 7. So the oxidation state will be 8 minus 7 equal to 1. For D and F block elements, the valency is variable. It is not constant. It keeps on changing. So what is the trend of oxidation state across the period? Across the period, oxidation state increases from 1 to 4 and then decreases. This is for the representative elements. Down the group, the oxidation state is constant because the number of valence electrons is the same in a group. Oxidation state for 18th group can be considered as 0. But remember, some of the 18th group elements also, under very drastic conditions, they undergo chemical reaction. We are just ignoring that fact for the present. Before we wind up the video, we will just see how oxidation state or oxidation number is calculated for a particular element in its ion or compound. A. Permanganate ion, that is MnO4 negative ion. B. Manganese dioxide. C. Potassium permanganate. And D. Potassium dichromate. In order to calculate the oxidation state, you have to remember 3 important rules. First one, the oxidation state for an isolated atom of an element is considered as 0. Second one, the total oxidation state for the molecule of a compound also is considered as 0. Third one, the total oxidation state for an ion is equal to the charge on that ion. In the first three cases, we will calculate the oxidation number of manganese. MnO4 negative ion. For ions, the total oxidation number is equal to the charge on the ion. Here the charge on the ion is negative. 1 negative. Oxidation number becomes negative 1. Oxidation number of oxygen is negative 2. Total for 4 oxygen atoms is equal to 4 into negative 2 equal to negative 8. Let the oxidation number of manganese be equal to Y. We do not know that. Then total oxidation state or oxidation number is equal to negative 8 plus Y equal to negative 1. From this, Y is equal to negative 1 plus 8 equal to positive 7. Negative 8 on the left hand side is transferred to the right hand side, so it becomes positive 8. So the oxidation number of manganese in MnO4 negative ion is plus 7. We have solved that question. Next one, manganese dioxide. Total oxidation state for the molecule of the compound is equal to 0. Oxidation state or number of oxygen is negative 2. For 2 oxygen atoms, it is equal to 2 into negative 2 equal to negative 4. Let the oxidation number of manganese be equal to Y. Then total oxidation number for the molecule becomes negative 4 plus Y equal to 0. Then Y is equal to 0 plus 4 equal to plus 4. So the oxidation state of manganese in manganese dioxide is plus 4. Remember, manganese is a D block element which has variable oxidation state. So in the previous problem, we got the oxidation number of manganese as plus 7. See, potassium permanganate. Total oxidation state for the compound is equal to 0. Oxidation number of oxygen is negative 2. Total oxidation state for 4 oxygen atoms is equal to 4 into negative 2 equal to negative 8. Oxidation number for potassium, it belongs to first group, is equal to positive 1. Let the oxidation number for manganese be equal to Y. We do not know that. So the total oxidation state becomes equal to negative 8 plus 1 plus Y is equal to 0. From this we get Y is equal to 0 plus 8 minus 1, which is equal to positive 7. Therefore, the oxidation state of manganese in potassium permanganate is equal to positive 7. D. Potassium dichromate. We will calculate the oxidation number of chromium. There are 2 potassium atoms, 2 chromium atoms and 7 oxygen atoms. Total oxidation state for the potassium dichromate molecule is 0. Total oxidation state for 7 oxygen molecules is 7 into negative 2 equal to negative 14. Total oxidation state for 2 potassium atoms is equal to 2 into positive 1 equal to positive 2. Let the oxidation state or oxidation number for 2 chromium be equal to 2Y. Total oxidation number therefore is equal to negative 14 plus 2 plus 2Y is equal to 0. From this, 2Y is equal to 0 plus 14 minus 2 equal to plus 12. Plus 12 is for 2Y. We need the value for Y. So Y is equal to plus 12 divided by 2 equal to plus 6. So the oxidation state or oxidation number of chromium in potassium dichromate is equal to plus 6, that is positive 6. If you think you got some help from this video, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. Thank you very much. Press the bell button and all button for notification of more videos like this. We will meet in the next video with another important topic like this. Till then, bye. Take care.